This is the LAN board's GVS board for the BeagleBone Black. What you're seeing is connections to all 12 GPIO lines. 5 of the GPIO lines are 5 volts and 7 of the GPIO lines are 3.3 volts. Each of the GPIO lines is being individually set to outputs. One channel is being set high at a time, and this results in one of the LEDs being on at a time. Also, there's some typical GVS sensors on the breadboard, such as a GVS push-button switch, buzzer, RGB LED, 5-way switch, and a couple of IR sensors. This is the BeagleBone Black GVS cape running PWM outputs on the 5 volt and 3.3 volt PWMs at the same time. The BeagleBone Black GVS cape has connections to 3 UARTs. One of the UARTs is 3.3 volts and the other 2 UARTs are 5 volts. To demonstrate the single 3.3 volt UART, we loop back the UART to itself by connecting its transmit and receive lines. We then run a terminal program on the BeagleBone Black and type into the terminal and watch the data come back. We can disconnect the cable and see that the data no longer comes back. To demonstrate the 2 5 volt UARTs, we cross-connect the 2 UARTs by connecting the transmit and receive lines of one UART to the corresponding receive and transmit lines of the other UART. We run 2 separate terminal programs on the BeagleBone Black. We can then type in one terminal and see the data come back on the other terminal and swap it around and see the data come back on the other channel. Here's the BeagleBone Black cape running a sample program that reads the A to D channel and writes it out to the LEDs on the test card. When you turn the potentiometer up of the A to D input, the LEDs go up, and when you turn it down, the LEDs go down.